Hello. How's it going, everyone? Olier Gonzalez again. Looking at the React Performance, which is a course taught by Steve Keeney, head front-end engineer at Temporal. And the goal of this course is to see how you can now write React components in the most performant way, therefore React applications. And in today's video, we're gonna focus on the React Dev. Okay, so finally now wrap this last section here when we talk about is the life cycle of our reactive effects, separating events from effects, as well as removing effect dependency and reusing logic with custom hooks. So especially if you need to see how you can optimize something, you need to learn how that things work. What is the inner mechanism behind that? And to do that, well, we need to understand that particular tool. In this case is React. So in today's video, I'm not going to describe all of the different topics here in detail. I'm just going to walk through all over these different sections to briefly describe everything that we need as to understand how do we get here with the effects. So because at the end of the day, React allows to describe this UI using JavaScript functions. We look at how can we now do that, import components and export components using the GSX syntax. How can we actually define our visual state or visual HTML, and how we can connect using curly braces to JavaScript, and then how can we pass down data to these components, how can we conditionally render components, as well as rendering lists of elements in that component, and also how important it is to keep our components pure. As also, what is the way of how now React create your architecture or see your components, which is this data structure, the way of how now React organize all of this data, all of these components. So you have now the render tree as well as the tree of dependency. The first is as a way to see how now React put all of these different components and how they relate each other, as well as how the data flow goes through that. And when it comes to identify is each one of these components, how you can now identify is bottlenecks, which is how you can improve the performance of each one of them. And also is the tree of dependency, which is the way of how you can now add all of this reusable logic in this component as a way to now bring interactivity, which is the way of how you can add that is by passing as a function or a handler functions to the event handler listeners. Okay, and when you want to show now data to the user and update that data based on an input, whether it's human or computer inputs, now you can is actually update that state, update that data by using his states, and how states allow you to remember things, how you can use now this piece of built-in component, built-in hook, as a way to remember things, as a way to identify which is the information that I want you to keep track in this component. Okay, and when I want to update that, what happened behind the scenes, which is the rendering mechanism. This is the phase of now React. When you update your state, it actually now pass through this rendering mechanism. You have the trigger, you have the render, and in the render say, hey, when this state update happened, if this was caused at the root elements, okay, let me now create all of these elements for that. which is actually looking at this particular moment. Yeah, like so. Okay. Um, no, this is this. But here is when they describe here. You know, it's like during the initial rendering, React will create the DOM nodes using as the create elements from the DOM API. All right, and going to store that information, okay, to be used in the next phase. However, if this in the commit in the rendering phase, if this was caused, if this state update was caused during a re-render, React will calculate is the properties and states since the previous rendering. Uh, so it's going to compute all of these properties in there, right? Rendering must always be pure calculations, saying inputs, saying outputs. It is minding its own business. In other words, you encounter confusing bugs and unpredictable behavior as your code grows in complexity. So when developing in a strict mode, React call each component function twice, which can help surface mistake caused by impure function. But during the re-rendering, React will now compute this everything actually fits using the strict mode. The that this component is a pure function, same input, same output, okay, and it is minding its own business. You should not change any object or variable that exists before rendering. So, and then it's going to now call the so once it compute that components, the output of that, if that contains more React components, it will call them in a recursive way until there is no more components. And then in the commit phase, as we now recreate this, or as we compute this components in the render phase, is when the VDOM is created or recreated, which is this ideal representation of the UI that you want to keep, that you kept in memory and you sync with the real DOM. And this is what allows now React as a way as developers to interact with the React API and indicate what is the UI that we want to be, and let now the React match that state with the DOM. So this process is now doing based on this reconciliation process, which is now is the React Fiber, or this reconciliation engine that actually the developers in React, they lay out the foundations to come up with some things that we are actually using in React 18. So they lay out the foundation in React 16 as a way to now allow us to do things, for example, like rendering prioritizations, such as user-defer or concurrent rendering using use transition, or the ability to pause, stop, and start a rendering. Okay. But all of this is something that how you can do that. Then how we need to think our state as a snapshot. How can we queue a series of state updates, and how can we now update arrays and objects in our states. The TLDR is that by passing always a new state. And when it comes to scale now our UI, or to manage the state, how important is to think in terms of how your UI state, or how your UI changed in terms of the state change. So by looking is at what is the different visual use, what is the different visual state that this component can be, and then identify what triggered those state updates. Following is the computer concept from state machines, uh, then you use now the state as a way to represent those UI state change. And I actually hit the brake here because this is what the this is what the represent. This is now the way of how in computer science you actually solve problems, real life problems. Why is that? Because I actually take a look at all of these data structures, for example, a hash, in arrays, in linked lists, and trees. And the idea here is that because now you have this way of organized data, and by using the arithmetic, which is the art of counting, uh, as well as how you can now is yeah, the art of counting. Uh, mhm, the art of counting, uh, and also how by using a geometry, you can actually use this as a way to represent stuff, and how important is to hit the brake here as a way to understand then how you can solve problems using this concept, this mathematical concept. So, for example, the counting, the representations, as well as the geometry. Okay, uh, this particular mindset will help you to actually know more about the intrinsic nature of how you can solve real life problems using this data structure, and ultimately solve the client problems, right? So this represents, and I know I'm actually quite talking too slow for that. It's like, okay, we get it, man. But the idea here is that truly understand that the vast majority of the time in computer science we want is to represent things as a way to solve a specific problems. So by using is the arithmetic, the numbers and that operations, the art of counting the number and the operation that we can do on numbers, add it, subtract, multiply, and divide. How by doing that and using these data structures, and also we can use this geometry as well. How by doing that we can actually come up with a solution to solve this real life problem. And that to me is quite beautiful because brilliant.org, for example here, no, so brilliant.org, okay, actually is giving us this particularly, okay, now they update that, yep. So brilliant.org is actually is giving us is for example, this course in math, solving equations, understanding graph, geometry fundamentals, vectors, system of equations, function quadratic calculus, and all of this. Logic and that kind of thing. Data analysis, exploring data visually, explaining variation, introduction to probability, predicting with probability, introduction to neural network, casino probability, perplexing probability, computer science and programming, thinking in code. Similar to science here, as well as an elective. What? All of our 70 courses are crafted by award-winning teachers, researchers, and professionals from Caltech, MIT, Duke, Microsoft, and Google, and many more. But the idea here is to actually pass down this kind of knowledge. I think that I already have an account here. Not sure if I have. I think I do. Wait, what? There it is. Wait, what? Okay. Please reload that. Better getting here. Oh, really? Mm-hmm. Really? Mm-hmm. Okay. Ah, they update this. Learning a specific skill. Building my problem solving skills. In math, bro. Yeah, man. In math. Mm-hmm. Let me start here. Oh, okay. What is your daily learning goal? Okay. Mm. Morning routine. Man, who made this? Who made this application? It's like, Of course, they're made in React, and they added all of this on XGS. Interesting. Okay. And Apollo and Versal and Chakra. Chakra UI. Mm-hmm. Another time a day. Might be mornings. No, start from the fundamentals, bro. Hmm. Oh, but this is real world algebra. Exactly, and I was looking at this, the mathematical fundamentals. I was looking at this, at the mathematical fundamentals, and how the things actually quake took quite amount of time here as a way to know any. This is something important because this is starting to develop your problem solving skills here, uh, and especially here in the mathematics and the can and this kind of thing. Why I'm actually stopping here? Because we were talking about is the representation and how represent here by using is now numbers or geometry, which is one of the things that actually is beautiful how we can describe this. See how you can now apply this. The TLDR is like anytime you're trying to solve a problem, first focus your attention into that. See how you can solve that. Determine what are the things that you can solve straightforward, uh, and then the things that you can now solve by going backwards. So thinking forward is a thing that you can specify quickly, and thinking backward is by looking at things uh, not only from a different perspective, but in thinking backward is also as a way of how you can is um, yeah, thinking forward is a specified word. Thinking forward is a specify the thing quickly, right? Thinking forward is to specify the things. Look at the thing that you can specify quickly. Okay. So thinking forward and backwards by looking at the thing you can specify quickly and keeping all the possibilities in mind, you can solve the problems more efficiently. So thinking forward is look at the thing that you can specify quickly, and backward as a way to keep all the possibility in mind. Okay, which is something that we do a lot of the time. But the TLDR of all of this, right, uh, is that now how we can actually use this as a way to represent is or UI. You know what I mean? So instead of actually and I know this is quite complex, but I want to make it the most simple and elegant possible. So this step, this representation, is how you can now is given this particular state, this particular building hook, how you can now is represent is state change. Okay, how you can represent is now those state change. So when those state change, you want to know what. Yeah, you want to actually is indicate to your React, hey, this is the new state that I want you to be. Hey, this is the new UI state that I want you to be. And then you are going to identify is or to determine what trigger those state updates. This is something that we're going to see that in detail when we are building is our own Trello clone. Because in that Trello clone, we want us to now identify is the different visual state. The initial visual state, okay, and what is the initial visual state, which is empty, with with car fields, uh, mm-hmm, with cars fields in that, and another visual state is that move that car from one place to another. So, all right. So, all right. Okay. So, but that's the whole point of this representation. So, as a way to now, after that, you're going to remove any non-essential states, and then connect the event handlers to state or to set this state. So this is the process that you're going to do, especially when you're going to manage your states and to identify is all of the different possible UI state using states. And then when it comes to manage your state, we also look at the principles here to do that. And I'm going to mention that, as well as how you want to share that state across different components. How is important to talk about in terms of functional control components and non-control components, and the subtle difference between them is how this component, how what is the main information that this component is driven. So is this the main information of this component is driven by it is props? They call this control components. If it is driven by it is states, it is called uncontrolled components. Uncontrolled components are useful for putting is all of these configurations where now where control components are helpful to now pass down some data and receive some data, so that they are much more flexible. The whole point of see how you can now pass on a state to different components is just as a way of when you do that, you're going to choose which components own that state. Therefore, that will become is a source of truth for any other components or any child component that make use of that. So this specific way of thinking, okay, followed by how to think in React, especially when you need to actually define all of this user interface. Mm-hmm. Especially when you need to define all of this user interface. So, for example, is you initially need to have is whether it is a well JSON structure or a data model or a UI layer that is provided by the UI designers. Either way, then you're going to now build is initially the components hierarchy. So if you have now your data model or your JSON is a well structured, that naturally fall is the components hierarchy, because that that actually is something that match the same shape as our UI components. Data models and the UI components actually match the same shape, the same architecture. If you're not, you can go is with the UI layer that is provide that. But in any case, you need to create is the components hierarchy here. And then you build an static version. This is when the data models are useful, because now you can is initially is write all of your React components. So typing your components is something or when you're creating these static versions, it requires a lot of typing and less thinking, which is great. In contrast, when you started to define is your interactivity, that does require a lot of thinking and less typing. The subtle difference here is that as you define is your components here, which is something that they're describing here, you know, as you describe your components here, and that's one of the things that they're using now a tic-tac-toe here, and I know how to actually make that, which is not that hard. Yeah, to me it's not that hard, which is something that we're gonna do, by the way. But yeah, you got this thinking in React is that you start with the mockup here, whether it's a JSON or the UI design, okay. Then you're going to break the UI into components hierarchy, as I mentioned before, okay. Whether it is most likely using is the JSON structure, because it naturally falls into that. If you don't have perhaps the UI design, that'll help you to do that vastly. And then you're gonna build a static version, which is now what is going to be rendering the UI without adding any interactivity, which is a lot of easy to build a static version first and then add the interactivity. Why is that? Because static versions require a lot of typing and less thinking, where now adding interactivity requires a lot of thinking and less typing. Once you build that static version, it is time to find now the minimal but complete representation of your state, of your UI state, which is adding the interactivities, indicating to React which is the state that I want you to render, or which is the UI state, that I want to represent here, which is something here, which is the UI state change that I want you to represent that match this state. Okay, and here when you define is, well, don't repeat yourself, so find a way to this is now how you let your users to change the underlying data model. Okay, and the most important principle of a structured state is to keep dry, don't repeat yourself. Figuring out the absolute minimal representation of the state your application needs, and compute everything else on demand. For example, if you're building a shopping list, you can store the items as an array in an state. Okay, so figuring out the absolute minimal representation of your state and need to compute everything else on demand. If you want to also display the number of items in the list, don't store the number of items in another state value. Instead, read the length of your array. And this is just a quite simple example of this. Which of these are state? Okay, identify the ones that are not first. So does this remains unchanged? That's not a state. Okay, is this information that I want to get remains unchanged? That's not a state. If this is past, if this is past, if this is passed in from a parent via props, so it's in a state. Exactly. So is this data, it is passed, yeah, so is this data, it is passed from a props, is this data, it is passed from a parent via props? That's not a state. This information, you can compute that from another state or a props, that's definitely not a state. What less might probably be a state. But the whole point is to develop this sense about what is an state, what is this information that you want to make these components aware of and update them. So as I mentioned here, this is what is a state. So the original list of product is passed as props. That's not a state. The search text seems to be a state since it changed over time and can be computed from anything. The value of the checkbox seems to be a state since it changed. Exactly. The similar for the checkbox seems to be an exchange because it changed over time. The filtering list of product is in state. The filtering list of product is in a state because you can compute that every time the component gets rendered. Okay, and the whole point of this is to actually see how you can do this. Props are like arguments you pass to a function, and states is like components in memory. So, and I mentioned all of this, which is something that I'm gonna put in practice in today's, yeah, because I'm going to build is this tic-tac-toe. Mm-hmm. Because I'm going to build is this tic-tac-toe. I think I already scheduled time for that. Do, do, do. I should have dedicated time to that as a way to build a trailer clone functionality. Yeah, it is. Yeah, it is. Yep, it is, my friend. Mm-hmm. It's a way to do that. Because I think this is something important. It's like, okay, you have all of the theory, and then how you can transform that into practice. That's all. So after after we find the minimal but complete representation of your UI, okay, by asking these couple questions, by identifying what is not on a state, okay, hey, is this data, is this information does remain unchanged? It's not on a state. If you can get this data from its props, that's not an state. If you can compute this data from its prop or from an state, that's definitely not an state. So after that, then you're going is to identify where this state should live, and therefore you're going to set now the state as a way to tell, hey, this is now the source of truth for all the components that actually need to that information, that state. So as I mentioned here, identify where your state should live. So after identify your app's minimal state data, you need to identify which component is responsible for changing the state. Which component is responsible for you need to identify which component is responsible for updating that state so that the user can see some data here, or owns the state. So changing or own that state. Remember, React uses one-way data flow and passing data down the components hierarchy from parent to child components. It may not be immediately clear which component should own what state, and this can be challenging if you're new to this concept. Very challenging, bro. But you can figure it out by following this step. So for each piece of state of your application, identify every component that render something based on that state. Hey, what are the components that render something based on that state? This is when you started to see that this will become is the source of truth for all of these components. Find their closest common parent, a component above them all in the hierarchy. Okay, hey, now that you identify every component that render something based on that state, you're gonna put in the closest common parent components, components above all of in the hierarchy, and decide where the state should live. Often you can put the state directly into their common pattern, which is usually what we do. You can also put the state into some component above their common pattern as well. Okay, you can also put the state in some component. Mm-hmm. You can exactly. You can also put the state into some components. Yeah, you can also put the state. Mm-hmm. All right. You can also put the state into some component above their common pattern. If you can find a component where it makes sense to own the state, create a new component solely for holding the state and add it somewhere in the hierarchy above. The whole point is to identify is where this component should live. Usually is at the closest pattern. Okay, so you can put that there, that information there. You can also put the state in some components above their common pattern, above their common pattern. Okay, or you can, if you can find any component where you can put it, well, it's going to now put these components Let's going to now put the states by creating a let's let's create a component that makes sense to put this state solely for holding that state. So in our particular case, after we now identify where this component should live, then we're gonna add this thing called add inverse data flow, which means that now um, change the state of our application, which components actually will trigger an state update of our application, and that is the add inverse data flow. So we need this to pass the state down to this component, to the child component, as well as the setter function. So this is something interesting because now this is what starting to give us the idea of how you can now build, for example, it's a tic-tac-toe here, for example, and also how can we now is when it comes to now deal with more, or when an input or when a state needs to deal with more and more inputs. So for example, whether it's computer or human inputs, such as a computer is rendering an image or waiting for this data to be low from a server, or humans like typing, clicking, navigating to a URL. So the more this information needs to react to more inputs, the more it make the more sense it'll be to actually is use something called a reducer, which is the way of how you can keep your state update logic consist, a maintainable, all right, by actually is using is the use reducer hook. Initially you pass is the reducer function, which is just a fancy way to say this is a function that takes an state and this is a function that takes an state and an action, and this action is a JavaScript object that contains a type property. What you're gonna put is now the type of action that you want to update to generate a new bit of a state. And this is what now behind the scenes React is gonna use as a way to now update this state. And as we look at this, how it makes a lot of sense to do that. And when it comes to reset or preserve the state, how can we is use how the state actually are tied to the position in the render tree, and how now it behave behind the scenes, which is it now actually put is the, so you have the same component at the same position in the render tree. React will preserve that state. If you have different components at at the same position in the render tree, React will reset that state. If you have, for example, now reset the component of the same, if you want to reset the state of the same component at the same position of the render tree, you can either render in a different position or put a key for that, which is a way of how now React keep track of this. And not only that, but also if you want to now pass data to different components, we use something called context as a way to now centralize is this state, this information, instead of actually passing that state and the debian head and the setter function along this prop change. Why is that? Because sometimes you want your components to show or not show something, and then alright, it'll make a lot of sense to actually use a context, because if that component is along the chain removed, data link is broken. So context help you to solve this very specific problems and to cover specific use cases. So, for example, like theming or small app level data, such as the user or the authentication or the analytics, as well as the the more inputs a yeah the more inputs a state needs to react, you can use this now a context as a way to now centralize there. There's a caveat with using context because React will re-render automatically any child components that make use of that context, starting from the provider, that value change. And as a way to solve or to prevent this unnecessary re-rendering, we use this catching mechanism like use Memo as a way to catch rendering, uh, catch computation between rendering, and catch computation between or catch functions reference between rendering using callbacks. So this is quite interesting, because now it allows to develop now a sense of how can we write our components, how can we describe of our state or UI state in React as a way to actually build this kind of applications. So build is applications like not only Trello clone, but also is for uh, some admin dashboard and that kind of thing, you know. Mm-hmm. Yep. So admin dashboard and that kind of thing. And I say admin dashboard because this is how you actually, and most of the time, a lot of the company actually are using uh, that right in the web. Mm-hmm. So in any case, then we look at now how we can, for example, when this component needs to communicate with external system or to connect or sync or to have control of that. Let's say you want to focus an input using the browser API, or you want to now play or stop a video outside of React, uh, or connect to a server. All of it you can achieve is by using is this specific hooks, and most of your application logic and data flow should not rely on this feature. But again, the reality is quite different. The reality is that we're building is this mother web applications that need to connect to external systems, to servers. So deal with that. But in any case, so we look at first how can we is now referencing values with ref as a way to uh, how to remember things without triggering a re-rendering, and how use ref allow us to do that. How use ref actually fits in the entire rendering mechanism. So it is initialized before the commit phase and assigned after the commit phase, so you can now have access to that particular elements or objects. What is the main use case to use ref as a way to now say we use this for timeout IDs or DOM elements or any JavaScript objects that is not relevant at the GSX computations. We also look at the most common example by using is not only timers, but also is DOM elements as a way to focus the input here. Yep, yep. As a way to focus now the input here on an element, or to scroll them, or to know the position of that element in Mm-hmm. 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 So, and how we can actually use is the use ref for that. And then when it comes to use effect, it's like, okay, now as a way to see how we can use is the use effect. All right. And therefore is what is the main use case, or what do we need to use effect? Uh, it uses a way to run this side effect code, or code that now alter the main functionality of this program, perhaps by altering is the global variables or data structures, or by performing its input and output operations. Uh, and here we look at the anatomy, the logic anatomy in our React components as a way to see we got is the render logic, which must be pure, as well as the event handle logic, which is in there you can is perform. So for example, is now the side effect code. But what happened when you want to now run this side effect codes? When the component renders, that's when you use effects. Where now initially you can do that by using this custom hook or this use effect, where now it will run these side effects caused by rendering itself. And this use effect now fits is in the rendering mechanism at the end of every commit. You know, so with this particularly knowledge, uh, okay, we also look at how synchronizing with effect. We also look at how when you're going to define your effects, especially in development mode, how React tells you first, you might not need an effect. If you are updating a state based on another state, you might not need an effect. In fact, you don't need an effect. Uh, and if you're going to work in development, or if you're going to write a effect, especially in development, how you must be aware of this particular process of setup, cleanup, and setup trigger function as a way to now make, as a way to react to make sure that your component actually uh, work as expected, or work with this synchronization process. And most of the time when you're writing your effects, it will typically fall into one of these patterns. You're connecting to an animation, or you are you are subscribing to an event, or you are connecting to an external widget. Okay, you are now fetching data, and here, as a way to prevent some common race conditions, how we put now an ignore flag and as false, and anytime we're calling is this network operations, if this is a new one on the cleanup function, we're gonna make that state update to false or to true in this case. In other words, because there is no way of how you can actually is uh, keep your keep your state update. there's no way to undo network operations. So that's why we need to put this false flag, or these flags uh, to false, uh, as a way to now indicate that React, hey, we don't want to work now with this data. We want to now update this with the new state. So all of this is just as a way to now first prevent race conditions, especially when your user is actually typing is a lot of the time here. And second is when the user now needs to deal with these different use cases. So for example, um, data or duplicate requests. Uh, yeah, duplicate requests, which means that this user effect doesn't run on the server. The server is the server will render this HTML. The client see now the loading screen. Then the client actually fetch the JavaScript code, only to realize now it needs to actually is perform a network request. So you need to solve these specific problems. The duplicate request. The other is network waterfall. So the more components actually need to make all of these HTTP requests to fetch some data, the slower your apps will get. And also you need to find a way to catch that response. So that's what you have now, frameworks like Next, Remix, or Gatsby that actually solve that, or some of these client-side library like USWC or React Query or React Router, and that makes a lot of sense. You know, and that makes a lot of sense because as we continue to describe this, okay. Mm-hmm. Yep. As we continue to describe this, now, how helpful? Yep. Now, how helpful for us is to, uh, mhm. Now how helpful for us is to actually identify it. The other is the sending analytics in there. And when it comes to actually identify when you don't need an effect, is that whenever things that you when you don't need to synchronize with an external system, you don't need an effect. And this is when it comes the life cycle of the reactive effects as a way to describe that particular process. Mm-hmm. As a way to describe that particular process. Okay. And how now the life cycle of reactive effects actually is working. Mm-hmm. Mm-hmm. Yeah, absolutely. Mm-hmm. Exactly. So the whole point of this is to, by looking inside the life cycle of reactive effects and separating events from effects, it's just a way to see now at the end of the day in the React effects, when you're writing your effects, initially it will trigger every after every commit phase when this component this will trigger anytime this component updates, okay, or caused by a re-rendering. So usually you don't want to do that. That's why you pass this now array of dependency and how the anatomy of this uh, use effect is, which is you have the setup, you have the cleanup functions, and the way how that works is quite different to the components lifecycle. When you have now the component mount, updates that states, and then you unmount that. But when it comes to the life cycle, it is important to think that as a separate synchronization process that you can either start and later on stop it. So this is something useful to understand, because as we define all of this use effect, and when you need to detect when an effect actually runs by passing it into the array of dependency, and how React determines when an array of dependency, when a dependency changed, by looking is, or by using is the object.is behind the scenes, uh, and how you need to use that reactive reference or that dependency inside of your effects, because after all, the effects run code that is reactive, run reactive code of block, run reactive code block of code, uh, and this reactive means that whenever props, states, or variable you define inside of your React components, it will at some points update it or change over time. So if you don't want to resynchronize, which is something that they explain here, if you don't want, for example, to resynchronize, right? Mm-hmm. So, for example, if you don't want to resynchronize your effects with your reactive values, you put outside of that. So, for example, you don't want to actually update a server or a server URL. That'll be fixed. So you don't actually update that. And there's sometimes, because at the end of the day, we want this to now, yeah, as I mentioned here, effects react to reactive values, and what an effect with empty dependency means. All variables, declarations, and components body are reactive. React verify that you specify every reactive value as dependency. The linter actually enforce you to do that. And what happens when you don't want to resynchronize? And when the process of resynchronize is that when you don't want to call is this process, is this side effects whenever the dependency change. So you can is not passing anything to the array of dependency, or passing is something or using an external variable that you define outside of the component. Why this is important? Because with that, all right, we were now able is to identify that the logic inside of your effects are reactive, which means that you can choose your dependencies because your dependency must be included in your array of dependency, and they must be reactive. And there are some times that can cause infinite loops. So if that is the case, so analyze your use effect. You might not need an effect, or you might need to split your effect. This is where the diagnostic step comes here. And if you want to read the latest value of props without reacting, but in other words, without actually triggering, is that there is now this way, which is especially here is now again, there's some pitfall here. There actually is in a beta state. Okay, so if you want now to read the latest values of prop state without reacting to it and resynchronize the effect. So let's say you want us to now read the latest values of props or state without reacting, and without reacting to it, and resynchronize the effects. Now here they have this specific case, which is to actually cover is the Mm-hmm. To actually cover is now the reactive part, which is the effect, with the non-reactive part, which is when you extract that into an effect event. And also avoids to put in your array of dependency JavaScript objects or functions, because this will cause to re-render every time. This will cause to uh, anytime you put that in your dependency, it will cause to actually or effects to resynchronize every time. This will cause to effects to resynchronize every time, and this is read about more removing effect dependency. So this specific case, especially when you are adding your effect of dependency, and then the effects logic is reactive code of block, which means that you can change your dependency. You must put is your reactive dependency there, and if that causing some troubles, so for example, running in infinite loops, uh, you might not need an effect, or you might need to split that effect into separate synchronization process. So for example, if you want to actually now is uh, read some props, read some value from props or states without reacting and synchronizing to the effect, uh, then you can now look at this specific use cases, which is still in alpha, and that is how you can now put is this reactive logic and the non-reactive part in an event, and how now and after that is how you can avoid is relying on functions and dependency, because they will be different on every rendering, or yeah, on every render, which actually will trigger an effect to resynchronize every time, and how you can remove unnecessary effect dependency. These two last section here, which is just the way of how after you understand is the effect life cycles, and then you understand is the anatomy, and what is the logic that you can put in there, and how you can now synchronize what actually synchronization means, and what is the uh, and how you can think now your react or your effect as this synchronization process that it can either start and then let it on stop. And this logic here, you want to know when this logic or when this side code runs as part of your event, as part of your array of dependencies. Uh, and as you do that, now how you can actually is um, not or passing data or values uh, without reacting, okay, or without passing this as an array of dependency. And now this array of dependency, after all, they are reactive values, and even though because you can change your array of dependency as a way to trigger now this reactive block of codes, how you can is now is um, identify that you might not need an effect if you're running into some issues like infinite loops in there, or to separate your effect into different synchronization process. And also when it comes to now wrong specific logic, wrong and specific effect logics, and also as part of the ability to read, if you need to read the value of an state or props without reacting to it and resynchronize with your effect, how you can use as an effect event for that, and don't put is property, yeah, and don't put properties and functions inside of your event handlers, right? Mm-hmm. Yeah, and don't put these objects or functions in your array of dependencies, and how to avoid that. And this is when now the effect again, but this is something that is um, this is something that is gonna tell you is that you're gonna you're going to describe now how, what is the difference between an event and an effect here. And then after all, effects are performed anytime the same interaction. So effects runs anytime the same interaction is performed. Okay. Or if effects run to a specific uh, is interactions. So they run after the same specific interactions. Where now the effects run is whenever you need that resynchronize, whenever you need to resynchronize something, right? And how you can extract in non-logic reactive out of the effects as a way to do that. But again, it's to extracting non-reactive logic out of the effect. And then removing effects dependency for that. So when you write an effect, the linter will verify that you include every reactive values like props and state. That effect reads is the list of effects dependency, and this ensures that your effects remain synchronized with the latest props and state of your component. Unnecessary dependency may cause your effects to run too often, or even create an infinite loop. Exactly. Unnecessary dependency may cause your effects to run too often or create an infinite loops. Follow this guide to review and remove unnecessary dependency for your effects. And dependency should match the code. Mm-hmm. And to remove a dependency, prove that it's not a dependency for that. Prove to the linter that it doesn't need to be a dependency by putting outside of that. Why suppressing the dependency linter is so dangerous? Because after you click here, okay. Yes. Mm-hmm. Okay. Mm-hmm. When you're going to write that, when you're about to write that, it is helpful to think of that like so. Mm-hmm. Okay. So that'll be all for this video. Take care. Bye bye.